What questions do we want to see do go over numbers 1 through 5? Have any of numbers 1 through 5 that we want to see do go over before we go to the next 3? So all of them we're using our equation up here or that format, y equals kx. But in number 3, we're using a and b instead of x and y. It says a varies directly as b. So in that case, whatever would come first, a would be like your y, b would be like your x. We're going to keep using a and b, don't switch it. But if you wanted to know how it's formatted, it would be like that. So we know a is 8 and b is negative 3. We need to find b when a is negative 16. So we have to find our k first, which would be our y over x, but in this case it would be a over b. So 8 over negative 3. That's going to be some fraction. If you don't have your calculator, go grab it. So we have our k value. Now we need to find the missing value. So normally this would be y equals kx. So this format is now going to be a equals kb. So we need to find b when a is negative 16, and we can put in all the numbers we know. So we know a is negative 16, k is negative 8/3, and we don't know b. So then to solve for b, we're going to take the fraction and flip it and multiply it. So do that in your calculator. Negative 3 over 8, put it in as a fraction, times negative 16. Use your alpha y equals to put it in as a fraction. Positive 6. And that would be it. Other questions in that section? Number 1. So in this, we just have to select which ones represent a direct variation. So if it looks like our equation up here, y equals kx, then it is direct. If it doesn't, then it's not. This one, the x is being divided, so that is not. Would this one be direct? Yes. It does look like y equals kx. It has a y-intercept, but the y-intercept is 0, which it needs. Is this one direct? No. Could we rewrite this? Two x over 3 is the same as y equals 2/3 x. Is that direct? Yes. So when you see this format, you have to also know that is direct. What about this one? Yes. Does it have a y-intercept of 0? No. No. So because of that, it is not. What about this next one? Also no. And this last one. Yes, because we can rewrite this. Y equals 1/2 x. Because you have your calculator, you could also do this if you wanted to. And your y equals, if something's there, put it out. You could start typing these in. So let's say I typed in this first one as a fraction 2 over x, and I tried to graph it, and my graph was normal, it would not look like a line that goes through the origin. So I could say this is not direct. This is actually inverse. Right. Other questions in that section? Okay. So we'll do an application, then move on to the next objective. So the number of gallons G of fuel used on a trip varies directly with the number of miles M traveled. If a trip of 315 miles required 3 gallons of fuel, how many gallons are required for a trip of 200 miles? So just based on, well, first, what's important here? Varies directly. What else? Number of gallons, and that we're calling it G. If it gives us variables, we want to use those variables. What else?
M is miles.
M is number of miles.
315 miles.
315 miles.
Required 9 gallons of fuel.
Required 9 gallons.
How many gallons?
We're looking for how many gallons?
For 200 miles.
For 200 miles. Right? Just like the problems we were doing last class, very similar. Whatever comes first is like your y, but we're using g. Whatever comes second is like your x, but in this case we're using m. So how would we set up this equation? G equals km. So it's going to always be in the format y equals kx, but in this case we're using the variables given. So then we can find our k. You can do this one of two ways. If you know that k is y divided by x, you could do that, or you can put these in, 315 and 9. Solve for k by dividing. I don't remember if that's a nice decimal or not. No. So leave it as a fraction. Simplify fraction, 1/35. And then here we know this is m, this is g. We're looking for g and we're given m. So in our g equals km, we don't know g. We know our k is 1/35, and we know our m is 200. Multiply those, tell me what you get. 40 over 7. You can put that as a decimal. What do you get?
5.71.
So with this, you have to think about, can gallons be decimals? Yes. So you could do 5.7, 5.71, 1 or 2 decimals is fine. And then make sure you have your labels because this is real world. So gallons, I shortened it. Questions on that before we go on to objective 2? So objective 2 starts with number 6. Do we want to see number 6? Yes. So these need to look like our equation y equals k over x. Does this look like that? No. This one does not look like this. but it is how we find k. So if I were to solve this for x, it now looks like that. So if you know that this is how we solve for k, or that you could solve it to get that, that would be inverse. What about this one? Does this look like that? No. What about this one? Yes. It doesn't matter that there's a 3 down there as long as the x is also down there. Now, if it had something outside of here that was not 0, that would not be inverse. What about this next one? Yes. And this last one? No, because the x is in the numerator. Questions on those? Flip to the back. Questions 7 through 11. Any of those we want to see do go over how questions are? 9. So in this case, given that y varies inversely as x, what is the inverse variation equation for the, that contains the 0.34. So it's telling us already we're doing inverse. We knew that already. This is the objective. We're back to using y and x. So that's our normal y equals k over x equation. They give us a point. That's our x and that's our y. We can use that to find k. If you know that k is y times x, you can go straight there, or you can put it into your original and then solve for k. It doesn't matter. So let's say I'm using the original. That would be 4 equals k over 3. Solve for k by multiplying. So that's part of it. We have our k now. Now we need to write that as an equation using our k in this. What would that look like?
Y equals 12 over 3? Which way?
So you're not going to use the numbers again, just the 12. So y equals 12 over x. So if it's looking for the equation, the only number should be your k value. Other questions there? 7, 8, 10, or 11? 11. Alright, the number of revolutions made by a tire traveling over a fixed distance varies inversely to the radius of the tire. A 12-inch radius tire made 110 revolutions to travel a certain distance. How many revolutions would a 15-inch radius tire require to travel the same distance? So revolutions is how many times a tire spins as you're driving. This does not have variables, so we can either use y and x or make up variables. What's important here? Varies inversely. So we know how we're going to solve it.
Number of revolutions.
Number of revolutions.
Fixed distance.
The fixed distance actually does, it's important in general, but not to this, really.
Radius of the tire.
The radius of the tire. Right, and then what else?
12-inch radius.
12-inch radius.
110 revolutions.
110 revolutions.
How many revolutions?
How many revolutions is what we're looking for?
15-inch radius.
And for a 15-inch radius. Right, so if you want to call this like n and r, that's fine. I'm going to just call it y and x. Whatever comes before those words is always your y. Whatever comes after is x. So I know the 12 inch is an x, the 110 is a y, the 15 is an x. What variable are we looking for? Y. Or if you changed it to something else, whatever you changed it to. So then we're going to find our k first, and then find our y. So just like before, to find k, we're going to multiply, but I'm going to set up the equation first. Y equals k over x. I'm going to put in my 12 and my 110. Multiply those two. What is K?
$13.20.
Okay. Then we're looking for Y, so that's going to stay the same in our equation. Our K is 1320, and our X is 15. What would our Y be?
88.
88 what? Revolutions. Questions on that? And then we can do 7 or 8 before we move on to objective 3. Or we could just move on to objective 3. Right, so number 8, if x equals 1/3 when y equals 13, what does x equal when y equals 1.9? It's confusing really only because of the decimals and fractions, but the method we solve is exactly the same. So we're going to use this equation. We have our x and our y. Put those numbers into your equation. So 13 equals k over 1/3. And then multiply both sides by 1/3. We're going to leave that as a fraction because it's not going to be a next decimal. So k equals 13 over 3. And then we're looking for x. We know what y is. So if we go back and put our numbers into this equation, 1.9 equals 13 over 3 over x. So you could do a couple different things with this. I'm going to show you probably the quickest one. This is a fraction within fraction. I'm going to take the x and get rid of it just by multiplying it to the other side, so I don't have to worry about the fraction within a fraction. And then I'm going to divide both sides by 1.9. But when I do that, I'm going to write it in the calculator a specific way. So I'm going to write the first one as my alpha y equals 13 over 3. And then I'm going to come out of it and just divide by 1.9. That way you don't have to worry too much about the format. It's going to give you a decimal, and that's fine. So then the x value you can say is 2.28. Questions on that one? Objective 3, what questions do you have there?
14.
Any others in that section? Let's start there. If we have more, depending on time, we'll do those. So 12 through 15 are just asking you to write the equation. So this is your joint and combine. It could be one thing, it could be a mixture of both things. S varies inversely as the square root of r. So we have different variables, and we know it's inversely. Remember that anytime you see inversely, you're dividing. S is like your y, r is like your x. How do you think we would write this equation?
Y equals k over x.
So use your s and your r.
S equals k over r.
K over, but it's the square root of r. To the square root of r. a lot of these equations, to set it up, they have similar questions down here as applications, like the inversely indirectly, the inversely indirectly. So whatever you set up here, you'll be doing similarly here, but then actually solving it. 18 is similar, but we're using cube instead of square root. So b varies inversely as the cube of v. How would we set up that equation? B equals k over b cubed to the third power. Then we can put in all the numbers. So b equals 2, we don't know k, v is 5, and it's cubed. So you can either multiply it all together, 2 times 5 to the third. You can figure out what 5 to the third is first and then multiply it. It's really up to you. What is 5 to the third? So then if I multiply 125 on both sides, you get what for the k value? 250. I don't have much space here, so I'm going to run into this bottom. Then we have to calculate b when b is 10. So we know our b value, 10, equals our k value, 250. We don't know v. So to find b, how would we start solving this? Multiply both sides by b cubed. 10b cubed equals 250. Divide both sides by 10. And then in your calculator, if you go into math, there is a cube root number 4. And you can type in the cube root of 25. And you would write that as your answer, 2.92. Remember that jointly is the same as direct. There are just more variables, so you're multiplying them all together. Are there any others we want to see you go over and have questions about? 13. So B varies inversely as F and directly as S. Take this one step at a time. How would we write this first part? B varies inversely as F.
B equals k over F.
B equals k over F. And directly as S. You can write this one of two ways. You can either put S outside, like next to everything, or you can write it as B equals, this is really over 1, so I can put K and S together. Either is fine. So when you solve 17, you could use either, and it would be fine. Any other questions? I'll ask for last minute questions when we come back from lunch, and then you guys will take your quiz. It is still collaborative and open note. When you guys come back, avoid this back table. Every other table is fine, but avoid that.